Well, everyone, hope you had a good weekend. First things first, I'm going to hand this around. I'm going to talk a little bit about what it means, but it's related to today's activities that we're going to be doing. I don't think there's too much to update on as far as things to consider. We're kind of in the thick of it right now. We will be starting NetSuite on Tuesday, or sorry, Tuesday, on Wednesday. I'm going to be updating some information online. There will be an item that will be in the grade book that's not going to look like a grade. It's going to be a fake email address. I'll explain the whole meaning of that on Wednesday. So if you see that email address pop up, don't worry about it. It's not a live or active email address. It's just a login piece of information that we need for our NetSuite accounts. So I just wanted to make you aware that that's going to probably come up between now and Wednesday. And then real quick before I start the lecture, with today's lecture, first of all, if you look in the week 4 materials, you'll notice that I've added a couple of documents. So one is actually a Word document, which is the copy, or the electronic copy of the handout that I just gave you all. If you want to work along, I also provided spreadsheets. This is the first time I've done the spreadsheet in this course. I just put it together before class. I thought it might be a nice counterpoint to what we're going to be talking about. If you want to download that and work along, great. It's mostly informal. I just want to kind of illustrate some concepts with relational databases. And then, of course, we were talking about DSP before class. Tomorrow's the Pie the Professor event. If you want to know what I look like after last year's Pie the Professor, you can see it out of my icon from some of my other courses. I was so excited about the Pie the Professor that I actually put this image for my advanced accounting information courses. So that has nothing to do with today's lecture. I just thought you all might get a kick out of it. Let's go ahead and let's talk about relational databases now. So recall from chapter 2 that systems become increasingly complex over time. That was something that we alluded to, not alluded to as far as why it is so important that we document system protocols. Early computer accounting systems, they were relatively simple, using conventional processing to mimic paper-based systems. Now, what that means is that when we think about the way that paper-based systems are structured, you can think about how you did transactions back in 220 and 221, and it was pretty simplistic and straightforward. That was kind of the same protocol that was used for early systems. Basically, the programs were written to look just like if you just written something on paper, and that was a logical step given the constraints of computers at the time. Now, the simplicity of conventional processing was appealing because it mimicked paper-based systems. It limited the overall depth of the AIS. Now, we're going to get into a little bit of detail about why that's the case, but I do want to talk about some just general disadvantages of conventional processing systems. So there's system and simplicity. They basically was simple to use, but it also was simplistic in the fact that it could not do much. There's a lot of inflexibility about data structures. That means that once you actually set something up with the computer, that was the form that you had to use. You could not manipulate that form whatsoever, which that's kind of hard to think about given the systems that we operate with nowadays that are so adaptive and can be modified at, basically at will. Inability to query data. So you've heard me use this term before, and I'm a big fan of using this term. When you hear the term query, that's basically just saying, I'm going to ask the data a question to get information. So query is a transformative process of turning data into information. And it's just basically saying, what type of questions can I ask that'll be meaningful to get information from the data? Early systems, you couldn't do that. You basically had to look at the data and what you had. You couldn't pull any detail. You couldn't ask the data, can I have a list of all transactions that occurred on September 9th? That's not something that was available in old systems. You had to be able to manually work through the systems themselves. Data redundancy is a major problem of conventional systems, and actually still is a major problem. So first of all, what does this mean? It means that the way that old systems were designed is that whenever you put in a piece of information, it had to be a piece of information that was unique to that particular data set. So say, for example, that I've got a few different data sets. So we'll say that I've got a data set for customers, I've got a data set for purchases, and I've got a data set for shipments. The way we would think about that now is that we would actually have one piece of data that would actually show the same individual who's going to be associated with the customer database, the purchases, and the shipments. But back when the older systems, they were 3 separate tables and they couldn't interact with one another. So say, for example, you have a customer named Kathy Otero. Okay, and then you have in the purchases transaction a Kathy M. Otero, which I don't know what Dr. Otero's middle name is. I'm just making it up. And then in the in this shipments file, you have Kathy Otero, PhD. Now, all of those are fine individually, but they create some problems. If I'm trying to look for Kathy Otero in the database and I see Kathy M. Otero, that might create problems for trying to look through the data because it's going to be different. Plus, if there's spelling errors, like if a name is spelled differently, or heaven forbid, if there's going to be situations where people will use different monikers in different situations, like my name is Michael Barnes, so I could go by Mike Barnes, and that would be a easy accident to have. Because the way the data worked is that we have redundant systems that do not recognize the same piece of information across the multiple files. Now, the reason I mention this is such a problem is that there are so many large databases out there that are built on systems that were created many, many decades ago. Some of the earliest systems are it's really impossible to kind of convert them to old systems. One of my favorite to poke fun at is the Internal Revenue Service, or the IRS. Anybody want to guess how old the system that they're operating in, what the original system that was created, how old it is? 60 years old. The infrastructure for the IRS is 60 years old. Now, notwithstanding the problems with having a 60-year-old infrastructure, obviously they're not operating on the same computers from 60 years ago. I'm saying the original system was created 60 years ago. Conversion becomes a real problem in the fact that a lot of the systems, a lot of the files that they meant to interact with one another were not made to interact with one another. So trying to figure out problems or figure out issues like trying to match information across keys, that was just not possible in older systems. And because they have such a stronger structure, so much quantity built into those infrastructures, that's really hard to convert. Imagine that you've got 200 million records from a 60-year-old system that you want to actually transfer into a new system. Does anybody want to hard key out 200 million records? If you really like hard keying information that much, if you like data entry, come talk to me. I can find you a pretty decent job here at Truman State. But my assumption is that you're in this classroom because you're not interested in data entry. And nobody really is, so it's really hard to make that conversion. Poor data quality, as I mentioned, there was not a lot of checks on information back then. Spelling errors were pretty common, and inconsistency of data inputs were really common. We're actually going to see an example of that in the file that I shared with you. Inconsistency of data formatting. There's not really consistent inputs about how data should be input. For example, if you have an invoice number in one file, it can be input as a character, and another one it can be as a numeric function because they're all using numeric characters. The formatting was not really specified. There was no real data dictionaries that specified how data was supposed to be input. And it was also just an inefficient use of resources. This kind of goes back to the analogy that I use kind of goes back to the automotive wars of the early 1980s. So if anybody of you are not familiar with that, the American manufacturers had to make some pretty massive changes because the way that they had manufactured cars is every car was its own unique entity. So the parts that were used in one vehicle were separate from the parts used in another vehicle. And then foreign manufacturers came into the United States and said, we can actually charge a lot less for our vehicles because we use a lot of the same parts in every type of vehicle. So we don't have to manufacture all these different components. Eventually, many American manufacturers caught up and figured that out. But it was an inefficient use of resources because they were manufacturing all these different parts just for these individual vehicles. They said we can actually streamline our processes. Same holds true here, is that if we're putting multiple resources or putting multiple pieces of information in every database, we could streamline it much more effectively if we could say, let's input it once and try to use it a minimal number of times. So modern computerized technology systems are the accounting systems. They're rooted in database technology. Now, database systems operate logically similar to a conventional processing system, but they avoid the physical structure issues. Now, logically similar basically means is the same types of tables that we would want to output from old conventional systems. We can still create those. The good news is that we don't have to store information specifically within that format. So it allows us to actually manipulate how we want to set up particular pieces of information. That means querying becomes a lot more effective because we know how we can access information and we can change the format of how we access information. To some degree, that's something that we've already done. We talked a little bit about it on Friday when we did some Excel activity. We're going to see a little bit more of that. Some of you may have taken other data courses like databases and seen how this works in actuality. But the idea being is that we store data once or at minimal number of times, not once, but In theory, it would love to be once. Some information has to be stored more than once, but most important information is stored one time, and then we just use that information across different platforms. So database is a collection of related data for various uses. There are 3 types of data models, okay? We're going to focus on the third type, which is a relational data model. Relational data model is a data-driven model stores information in the form of related 2-dimensional tables. The reason that we use the relational data model is, first of all, it's the most common and popular to use in today's accounting infrastructures. But probably more importantly is this is going to be the one that you have the most familiarity with and the one that's most easily adaptive for what uses we're going to be using it for in this particular course. So relational data model basically says we're going to identify relationships between tables and use those relationships to manipulate how we actually query the data. So relational data models allow designers and users to identify relationships when the database is created, or much later whenever new requirements for the data model are desired. Now, this last statement is really profound because, as I said before, conventional processing systems, you could not manipulate format. You cannot manipulate form. If you wanted to have a new piece of information, then you had to create a new table, and a whole entirely new mechanism had to be created. All the inputs had to be put in. You couldn't just create something from scratch, or you couldn't just create something from what you had. You had to create it from scratch. The nice thing about relational data models is that we can actually set up our queries in the current format. But if we decide we want to have new information or be able to query the information in new ways, it's set up to do so. We don't actually have to define everything that we need from the data up front. We can actually we can change the data format and pull information that pull detail that we need as we need it. So advantage of the relational data models: flexible and scalable. They handle changes quickly and easily. So these are going to be kind of the systems that we talk about in this course: SAP, Oracle, and Microsoft. By the way, the one that we're going to be using on Wednesday, it's called NetSuite, but it's an online version of the Oracle system. Definitely not as complex as an Oracle system, but it will have features that will mimic those. It's simple. It's easy to communicate with both users and developers, and probably the most important one is there's reduced information redundancy. Most data has to be only recorded once. Now, this is a bit of a misnomer because if I said everything only had to be recorded once, that would create problems because some of the things that we're going to be recording are keys. And the keys are going to be used to relate the tables to one another. So if we don't have those keys in multiple places, there's no way for us to relate that information. So most data can be implemented once. Our keys often have to be implemented multiple times. So what are the elements of a database system? So these are kind of important to note because these are what define how we utilize these systems in practice. First of all, the data dictionary, which we talked about in chapter 3, but I want to reiterate. This describes the data fields in each database record, such as a field description, field length, field type, etc. So some of this is really, really critical to be able to define in advance. One of the examples I said, an invoice number field. Should that be a character field or a numeric field? So say that you have an invoice number that's all numeric digits. Should we input that as a number or a character? And the answer is it really depends. All right, it really depends on the characteristics of the database itself and what type of queries you're going to be running. Oftentimes, when you hear me talk about running data, I will say anything that's not something that we're going to sum together, like an amount field, should be entered as a character. So even though it's all numeric digits, I would say this should be a character field. Now, some people will disagree with me on that. They'll say I would like to leave it as a numeric field for various reasons to actually for actual flexibility of input, but that has to be defined in the data dictionary, and that's something that we need to clarify. Why is this so important? Let's say that we've got invoice number that's going to be a key to another field, or a key to another table. In our invoices table, it's entered as a character. In our table that's trying to be matched to, it's entered as a numeric field. Has anybody ever tried to run a VLOOKUP in Excel and tried to match a character field to a numeric field? We actually did that on Friday, by the way. The answer is yes. Yes, we have, Dr. Okay. We did that on Friday, and what happened in that situation? We came up with a £n/a, which is not anything you'll ever like to see. It means that we couldn't run that query. We couldn't run that formula. We had to actually make the adjustment over to the character. We had to change the character field to a numeric field in order for us to be able to run that particular formula, which is an example of that particular problem that we run into. Some other things, some field descriptions. We'd want to know what type of information goes into the field. Field length is a pretty interesting one. So say, for example, that you have a field for social security number. What should it specify? Should it specify that this should be a 9-digit field? If it's fewer digits or more digits than that, it's an invalid entry. So we can actually set parameters which will allow us to actually manipulate what information goes into there, or shouldn't say manipulate, control what information goes into there. The database administrator, this is the role that we will all be playing on Wednesday. So this is the person responsible for design, implementation, repair, and security of a firm's database. I want to make a note of this, and you will hear me say this multiple times as we're walking through NetSuite, and it's really, really important to remember. Even though we're going to be accessing all parts of NetSuite, the database administrator traditionally does not have any functional role other than administration. They're not going to be inputting journal entries. They're not going to be managing tables. They're not going to be doing a lot of things that we're going to be doing. The reason that we're going to be playing the role of administrators is that that gives us access to the entire platform. So as we walk through this, please make sure that you take diligent notes when I say this is somebody who would be involved in sales, or this is something who'd be involved in purchasing. This would be an executive within the organization who would do this approval. It's going to be different individuals for every different tasks, even though we're all going to be doing those tasks simultaneously together. It's important to note the database administrator has access to the entire system, but only for maintenance purposes, not for actual operation purposes. And then the database management system. So the database management system, this is designed to manage data in response to programs to users. Basically, the idea being is that we're going to make requests of the database management system, and that is what will return the information that we need back to us. So let's go ahead and talk about some components. Again, these are going to seem very familiar because these are all things that we talked, or a lot of these things are things that we talked about on in chapter 3. But I want to reiterate them, and we're going to relate back to some of the things that we discussed. So entities and attributes, these are kind of characteristics or not characteristics, components of relational databases. So entities we've talked about before, but we referred to them as classes previously. And this is how we characterize those within our UML diagrams. So these are items about which the relational database, which information is stored. Now, classes are going to be grouped into resources, events, and agents. And these are our primary ones, okay? Remember there were 4 of them. We'll talk about the last one here in just a second. But an event is a business activity. A resource is usually an asset involved in the event, and an agent is an individual involved in the event. So that was the easy way that we categorized those UML diagrams. And the good news is this rolls over to our relational database. Now, there's a 4th item I didn't include on the slide, but we have to remember back from chapter 3. Does anybody recall what that 4th class is? I said someone's outlier. Yeah, conceptual structure. This could also be included within the database. Usually when we talk about a conceptual structure, it's something that we want information about, but doesn't fall cleanly into one of these other 3 areas. And we're actually going to take a look at that here shortly. So attributes are characteristics, properties, or adjectives that describe entities. And we generally classify attributes according to columns, okay, to what's put in the columns. How does that delineated within a relational database? Well, first of all, let's go ahead and take a look at the entities and attributes, some examples of each. So resources, we know cash and products, events, sales and purchases, agents and customers and salespeople. It's important to note, and this is going to be very confusing once we get to our example. Specifically, when we talk about agents, these are individuals that are involved within the event, individuals that are involved in a specific event. So we need to be able to define, is an agent somebody who's actually involved in that event? It's not just any individual that is loosely connected to the transaction. And that's going to be an important distinction to make. So then we have attributes, characteristics, so customer IDs, addresses, or properties, invoice number or date, and adjectives, product names or prices. And the reasons I say adjectives, that word is a little bit dicey to me. Those are not really actually adjectives, if you'll notice there, because product name is a noun. As price, I don't know how you would clarify that. I'm not going to put that in front of a noun and say, well, this is defining the noun. So I'm not sure how you would clarify price within the verbal context of English language. But that's actually how they define adjectives within the book. So I'm sticking with it, even though I put a big question mark there. Regardless of how you're going to clarify that from a correctness perspective, attributes are all items that define whatever the entity is, defines the entity itself. Now, let's go ahead and make the distinction, because we've already made this distinction before, but it's really important to clarify this and make sure that we have we're actually at full clarity on this. So the 3 main constructs that comprise our relational database. Again, this is not difficult, but it's really important to make the distinction. So the first one's going to be the table itself. And it's often characterized as a relation. This is our primary construct used for data storage in the rows and columns, much like a spreadsheet. Each table in a database represents either a class or a relationship between classes. Now, for the most part, we're going to be talking about a class, but oftentimes we can talk about relationships between classes, particularly if there's not going to be a way for us to make a distinction between or to actually define a relationship clearly. And we're going to look at that and make sure we're understanding. So a table does not have to specifically be an entity. It actually be a relationship between entities, particularly if we do not have a one-to-one relationship to define those. Within the table or the relation, we've got the columns, which we've talked about. The columns are the attributes, okay? We often call these fields. So when you hear me use the term field, I'm talking about specifically a column that's used to define the entity itself, all right? So attributes are characteristics of the class or relationship. And then finally, rows, which I know everybody knows rows, but what does a row represent? And basically, that's an individual instance of every entity. So customers are an entity. Each row would be an individual customer, okay? Customer ID 1, Kathy Otero. Customer ID 2, Stacy Caden. Customer ID 3, Michael Barnes. Those would actually be individual instances. You probably heard of these referred to as records. Some of you may have actually heard the term tuples used before, but they represent all specific data values associated with that one instance. So a customer's table, a customer's relation, would have the record or the records for all the customers that are within the entity. Okay, so this is kind of an example of this. This is a picture, a screen capture of Access. We won't actually be doing Access in this particular course. We're going to limit our discussion primarily to Excel with respect to relational databases. That being said, we will definitely see these relations when we get to Power BI, and these relations are going to kind of drive how each of the tables interact with one another. So understanding the relations between tables is really, really important. But we're going to get to that. So this is kind of our customer database, and actually it's inventory database. Okay, sorry, my bad. And you kind of see this is the table itself is the inventory table. The field basically describes the inventory, and then each of these are different types of inventory that the organization has. Now, there's some things that it's important to note here, and we've alluded to these already, and I'm going to reiterate some of the points here. So there are a lot of rules that go into correct modeling for a relational database. And again, I don't particularly like rules because rules require memorization and not understanding, because the rules themselves are easy to understand. I'm going to try to focus on some of the primary rules, but you do need to understand all of the rules as we go through these. So first of all, let's go back to our concepts of primary key and foreign key. So primary key, as we defined, is a primary key uniquely identifies a specific row in a table. So go back to the previous table, and you will notice that this inventory ID is our primary key, and this uniquely identifies. And you may say, well, could the name be a primary key? And the answer is, usually we don't use verbal descriptors as primary keys, simply because it's too easy to have the same verbal descriptor. So you like to have vanilla, and then you have another version of vanilla, like French vanilla, but somebody still calls it vanilla. Okay, are they both correctly identified with an attribute of vanilla? Absolutely. Is that a primary key? It's not. So usually we're going to have some numeric identification or numeric alpha combination that's going to be associated with that. Okay, and we talked a little bit about that on Wednesday last week. We said, what is the primary key for the individuals in this classroom? And we said banner IDs. All right, banner IDs avoid that conflict. Everybody in this room has a unique banner ID, including myself. I've got a banner ID within the Truman system as well that kind of defines their roles within the system. We also have foreign keys, which is an attribute in one table that acts as a primary key in another table. And this is an important distinction to make. Foreign keys are how we actually identify a lot of our relations between tables. An easy way to think about this is we can think about a customer and a transaction. Within the customer table, a customer ID would be a primary key. But we would probably also list that customer ID field within the transactions table, sales transactions, because we'd want to know which customer was involved in the sales transaction. That would not be a primary key in the sales transaction table, because you could have customers that never make a purchase, or you could have customers that make many purchases. For a sales transaction table, you probably have a sales transaction ID as their primary key, but we can match it back to the customer information by using that as a foreign key within that table. Now, again, if you're not clear on how that works, trust me when I say we're going to get to that. We're going to talk about it a little bit more length in just a second. We're also going to have a lot of examples over the course of the semester that will make it easy to note. But it's important to say that whenever we have a foreign key, a true foreign key, the foreign key is going to be something that comes as a primary key from another table. Now, I want to make sure that we're clear on something, because this is going to come up and it's going to be a little bit confusing. It's not necessary for most tables, or not necessary for all tables to have a primary key, okay? Those are going to be the ones that we talk about relationships between keys. We do want to actually say that we're going to have some sort of key, and we may see tables that are to have not primary key or foreign key, and it's going to get a little bit confusing. They don't explain it well in the book, so that's why I want to mention it now. So that can come up. We're going to talk about why that's the case, and it has a lot to do with the multiplicities that we identified back in chapter 3. But moving on to a little more discussion, okay? So we can kind of see some examples of primary keys that are listed here. You can kind of see the customer table and the sales table. The customer ID is the primary key within the customer's table, but it's a foreign key within the sales table. Similarly, that product number, or this product number field is also a foreign key in the sales table, but is a primary key in the product table. All this serves as is that when we look at the sales table and we want to pull information on a particular transaction, we refer back to the original resource that provided the primary key. So say, for example, I look at this transaction right here, this invoice right here, and I say, I want to know information about customer 602-966-1238. I can pull that information from the customer table and say, this was to somebody named Mark Wagstaff, who's at 168 Apple Road in Rockville, Maryland. That information is not stored in the sales table, but it is available through the relations that we develop between the two tables. That is why it's considered to be a foreign key. It allows us to acquire information from other tables, allows us to do those matches. Okay, so this is where things get a little bit dicey. These rules tend to get a little bit confusing. I want you to note, you should absolutely 100%, without a doubt, know the first two rules cold, okay? Because these are going to be very, very relevant. That does not mean you shouldn't know the other 4 rules, but they're going to be less prevalent and come up less frequently. But make sure you have a good working understanding. This does not need you to memorize them word for word. I'm not going to ask you to regurgitate them word for word, but I would ask questions on these on an exam. So the first one's called the entity integrity rule, and primary keys must have data values. Okay, they cannot be null. We talked about this on Wednesday last week, and it's an important characteristic to note. For a primary key to work, it has to be a unique identifier, and it cannot be a null identifier. That was one of the reasons we could not use social security numbers as a unique identifier for students at Truman State. We have some international students here. International students do not have social security numbers. They would have a null value in that field, which creates problems for identification purposes. So we have to have a primary key, and it must have a value for every single one of the records. A unique value, important to know. The referential integrity rule relates to foreign keys. Now, foreign keys must either be null or match one of the data values that already exists in the corresponding table. Now, this one is really confusing, okay? I said primary key, I say foreign keys represent a primary key from another table, and that is a correct statement, okay? So the confusing part says, how can a foreign key be null, Dr. Barnes? And the answer is it's a little bit complicated to think about. So I want to kind of step back and I'm going to do my kind of traditional analogy of using food, okay? So example, let's say your example, what's a good place? Like Jimmy John's would be a good place in town. Where do you use that? I never use Jimmy John's as a reference, but I eat there a lot, which is weird. Yeah. So Jimmy John's, my frequent way of ordering is I go on the app because I've gotten to the point where I'm actually able to go on the phone and use an app. It took many, many years for me to get comfortable with using apps, but there you go. I go and order on the app. And so there's a transaction associated with that app. So they're going to look at my record and say, okay, this is customer 12345, or customer number 1, because I've been eating at Jimmy John's for a long time. So customer 12345, this is Michael Barnes, and they've already got my demographic information on the table, and they're going to be able to match this transaction with my particular record. All right. So does that mean every single sales transaction is going to have a customer ID associated with it? Well, how many people have actually just walked into Jimmy John's and ordered from the register? Has anybody ever done that? Nobody's ever done that in the history of Jimmy John's ever. Obviously, that happens quite frequently, okay? Are they able to pull up customer ID information if they do that? Like say you pay in cash and you say, I refuse to give you my identifying information, which obviously it's not a discussion you're going to have, but effectively, you know, if you don't tell them any more details about yourself other than this is my first name, which you could even make up, which by the way, I used to do all the time at another sandwich shop because they would write your name on a bag and I would try to make up the most ridiculous names I could come up with. I definitely do not look like an Eduardo, but I use that name many times, okay? Anyway, getting back to the point, they're not going to actually have information that's going to be related to that customer ID. So they have a sales transaction, but in that foreign key where they're trying to identify what is the customer identification, it's blank because they don't have that detail for people who pay with cash in the transaction. Probably most people who pay with anything that walk into the store and just make a purchase. That does not mean there's not an identifier. It means they don't know what it is, so they leave that field blank. So it's possible to have a foreign key with no identifier that can have a null field if it can't be matched. That does not violates the integrity of the foreign key. It just means that that piece of information is not available for that particular transaction. Now, there's going to be more examples that we'll see of that. That's just an easy one to pick up on. That given the circumstances of the transaction, we may or may not be able to refer to that foreign key. If we went back to the original table where that foreign key was a primary key, that one's going to have all the transaction or all the details for all the customers they have data on. Just means that the customer came in, they didn't provide that information, or they're not part of that table, one of the two. So each attribute must have a unique name. Now, this one seems like a really, really straightforward item. You would be surprised how difficult it is to actually make this work in practice, particularly if you get really big tables with lots of attributes. When I was dealing with the data analysis back in KPMG when I was doing this, we'd get these tables that had like 200 columns, and eventually somebody just stopped naming columns, and they just basically said column 1, column 2, column 3, column 4, and there's no definition of what these are. They were just kind of like, I'm not filling out the data dictionary. This is too much information. It becomes really, really challenging for really large data sets. We're not going to be dealing with anything that large, but keep in mind that you do need to be able to specify unique end names for the columns because they're going to be unique attributes. Each value attribute must be the same type. This is pretty obvious. If you got one that's numeric, everything in the column should be numeric. If you got one that's numeric and then one that's a character and then one that's something else, it creates problems for the analysis. There is possibility that you could enter information that's numeric and another column enter information that's not numeric. So for example, a customer purchase order. So your customer sends in a purchase order, and so one customer sends in all numbers, another one sends in a combination of numbers and characters. We would just characterize that particular column as a character field. That's all we would do with that. Everything needs to be consistent. Each attribute of a record can only have a single value. This was a really important one because we talked about this last Friday. I was saying, why can't I use this as a foreign key within a table? And I said, if I try to use it as a foreign key, what happens? I pull out 3 records, each with a different value. According to this particular rule, I'm only allowed a single value for an attribute. I can't put in multiple values. So it violates that rule, which is an important rule. It's why we can't use certain items as foreign keys within tables. A non-key attribute should describe the characteristic of the relation identified by the primary key. So the primary key basically has a unique identifier, and all other attributes should actually be some unique characteristic of that. So whether it be name, whether it be address, whether it be email or phone number, all of these need defined attributes within that. So a lot to keep in mind, but it's really, really important that we do that. It's really important that we actually have that. So what I want to do now, and this is going to be somewhat informal, but I handed out this piece of paper for you. And this in the past, this is all we did for analysis. But I thought, this is really not enough, because if we just look at this information by itself, it really doesn't tell you a whole lot. So what I want to do is I want to start out just talking about this information, and then I want to go into Excel and do some quick diagramming and see if we can understand these relationships as they exist. Okay? So we have 5 tables here. 3 of these tables represent kind of traditional entity tables, and then 2 of these are relationship tables. So the first one is author, and that's basically the authors of a book. And then the second one are going to be the books themselves. Now, this is pretty straightforward information. You can kind of see that they have got their primary keys listed as the first keys or first fields that are listed there. So author ID and book ID are primary key identification. Now, the interesting question comes in is that can I use the author ID as a foreign key in the book ID field? Could I take this author ID and kind of put it over here as a foreign key over here? So I know some people are kind of like saying this is going to be a trick question because I want to say yes. Some people have said no. The answer is no, but the question is, why can I not move this author ID over to the book ID field? So is it possible that books could be written by more than one author? Yes, books can be written by more than one author. In fact, pretty much all your textbooks that you're using currently in the class are written by more than one author. What did we just say? What was one of our rules that we just talked about? Each attribute of a record can only have a single value. If I list out the author of the book, it's going to have multiple authors listed. That's more than a single value. We're going to talk about how to address that in just a second, but I want to switch it on you, okay? Okay. Could I put the book ID into the author? Could I take this primary key as book ID and put this as a foreign key in the author ID field? Answer is still no. Why? Could we have it where authors write more than one book? Yes. That's the weird thing about these book authors. Sometimes they say, you know what, that book was so much fun, I want to do it again. Some authors write multiple books, so we can't actually do that. That's that one-to-one relationship we were talking about with our multiplicities back on Friday. I said that has to exist in order to use a foreign key. But if we've got many books, okay, we've got many authors, then we can't have that relationship. So how do we solve that problem? You'll notice that we've got this relationship table here. So we got author ID and book ID, and this actually aligns all of our authors in our books. Now, it's important to note, neither of these is a primary key because there's not a unique identifier for either one. And neither of these represent a foreign key, a true foreign key in the table, because they're not unique identifiers. They are primary keys from the table, but they are not unique within that table. So basically, these are relationships here. I guess actually, technically, you couldn't find these as foreign keys. I was kind of the items not unique identifiers. All right, so then we have customers, and the customers kind of follow the same pattern. I talk about this. And then we have the sales line item table. Now, I want to talk about this sales line item table because I don't like the way it's set up. If I was going to go for this traditionally, what I would do is I'd have two tables, okay? One would be our sales transaction table, which would actually have a transaction ID, and there would not be as much detail listed. And then we'd have a sales line item table, because the sales line item table could say more than one item was sold in a transaction. So let's list each of these items that were sold within an individual transaction. They apparently in the book decided not to worry about creating a transaction ID or a transaction ID table to try to leave it alone. Technically speaking, what we should do is we should have a transaction table that should actually have a list out of all the transactions that are listed here. And then the line item table would talk about every single line, every single book that was sold, regardless of whether it was in the same transaction or not. All right. So this is kind of some detail, and by the way, this is kind of a same type of situation we talked about the sales line item table. This is a relationship table. I would much rather have had a transaction table because the transaction table would have been very enlightening. Because in the transaction table, we would have had a transaction ID. We also would have had a foreign key for customer, because traditionally, in most situations, one transaction, one customer. Okay, so that makes a perfect foreign key in that particular situation. But ignoring that, let's go ahead and take a look at how we can analyze this information in Excel and why a relational database has become so important in this context. So I put all these items into Excel. And by the way, I did want to note, remember we were talking about incorrect data inputs. This would be one of those quality checks that I check right here. Because presumably somebody at McGraw-Hill was just kind of like typing in and making stuff up. So they had Jennifer Brown and they misspelled Jennifer in the email address. Or either that, somebody just really likes having two F's than Jennifer. I don't know. That was just kind of clarified for you. This is one of those things you want to pick up. But anyway, we have our author and book tables, which I said author and book are primary IDs. Then we have author to book. Now, why did we create this table right here? So could I use this table to query for more information if I wanted to say, all right, I know that I've got the two authors here, and the one author here that's written two books. Okay. Could I actually say, I want to know what the names of the books that this author has written? Yeah, and it's pretty simple. Let's just go ahead. I'm just going to run a quick VLOOKUP. And we're going to run it on this one right here. We go back to book. I'll highlight two columns. By the way, if you're not catching everything I'm writing right here, it's fine. The query itself is not all that important. What you can kind of see here is that we've got author number one, which I could pull that user's name as well, has written two textbooks, Cost Management and Intermediate Accounting. Author number three also wrote Cost Management and Accounting Information Systems. By the way, it's a crime that they included tax as one of the textbooks, but did not include an auditing textbook, because tax is not even real accounting, if you know what I mean. So they should have replaced that, but right, yeah, I guess that's just the preference of the authors right there. Anyway. Then we have the customer, and then we have a sales line item. The same thing holds true here. If I want to know the customer's name or any of the customer details, I could use this detail or the sales line item to pull up the customer ID information and pull that over. But what I'd like to do is I'd like to talk a little bit about the relationships here, okay? So this allows us, so the reason that these relationships exist is because we understand that relationships exist between each of these tables. So, or at least the entities that are represented in these tables. Two of the tables are not entities; they're more relationship tables. But like we've got three sets of tables, and one of these that kind of alludes to the existence of another entity table, which would be our sales table. So let's just go ahead and define this for UML purposes, okay? What is our event from the, or if we want to create a UML diagram, which of course I did, but if I want to create a UML diagram, what's our event in this particular scenario? So buying the book, so the sales transaction, okay? All right. Who buys the book? Who's the agent? The customer. Now you probably gonna say there's an employee agent too, and I would agree that if we extended this out, there would be an employee as an agent as well. We don't have employee information within this particular table, so we're not going to include that as an agent. We're just saying the customer is our agent right now, okay? And what is the customer buying? What is the resource that they're purchasing? The book, okay? All right. So we've got resource, the book, event, sale, agent, customer. All right. And we can actually define those relationships. Now, before we do that, before we take a look at the UML diagram, there's one entity that's listed up here that doesn't seem to fit. Is the author an agent in this particular transaction series? Is the author involved in the sale? It's like they walk into the bookstore and says, "That's a good book. You should buy my book." Okay. Okay. That would actually be a unique scenario, but probably does not happen. Okay. You probably do not see the authors of the textbook in here standing over there in the bookstore asking you to buy it. So how could we characterize the author in this scenario? The author has a relationship to the book, or the relationship to the book, but it's not going to be a resource event or agent relationship. So what we characterize the author as? A piece of information about the book. So we call that conceptual structure. Okay. So let's go ahead and look at the UML diagram. And you'll notice I have the conceptual structure listed up here. But we can define this pretty easily. And these multiplicities actually belie a lot of information about about what it is we're seeing within the relational databases, okay? So first of all, let's take a look at the really important one. So a sale can have one customer and only one customer. What does that mean about that customer field? It means that customer field can be used as a foreign key within the sales database, within the sales table. We can actually identify who was involved in that sale using that as a foreign key. That is the only one-to-one relationship in the table, which means that it's hard to use anything else as a foreign key because we don't have that, and any other primary keys as foreign keys. That's why we have to create those relationship tables, because we don't have that one-to-one relationship. So let's just go ahead and see if we make sure about understand what the multiplicities are. So authors can write one book, or they can write multiple books. If they write 0 books, they're not an author, okay? They're not an author, they write 0 books. Books have to have one author, but they can have multiple authors, okay? So multiplicities there make sense. So books can be involved with 0 sales. You can have a book that never sells. It's happened to many aspiring authors in the past. Hopefully not too many people, but you know. But they can involve many sales as well. Sales have to involve one book. You have to have at least one item to have a sale, and you can have many books in the same sale. The sale involve one customer, only one customer. Customer can have 0 sales. Again, this is the traditional one that the book is sticking with. The textbook, our textbook, is sticking with, saying that a customer could actually not have made the purchase yet, or they could be denied credit. They could have their transaction turned off, so it's possible for be a customer but not have a sale. But customers can also buy many or have many sales. You can have repeat customers as well. So pretty easy interpretation here, and that actually that's what defines our relational databases or relational database setup that we have here before. So if we were to actually put this in Access, then we could define the details even more further. We could actually pull information from one table to another to be able to actually determine what the relationships are within the table. And like I said, some of these are pretty easy. Like I want to know the books and the names of the books. I want to know the names of the authors. In the sales, I want to know the names of the customers. This is all possible because we have these defined relationships. If the rules are not held, and if we don't actually have consistency between the information in the tables, we do not have relational databases, and that creates the problems that we would see. So it's important to make sure that we have the integrity within those rules that we talked about in order to be able to utilize these tables effectively. Now, they're not going to take as much in-depth look in this. Again, this is more for a databases class, and again, this is not a databases class, but it's important to understand the basics of relational databases because these define how our information systems work in the modern day and age. All right, that does it for today. We are going to be back in here on Wednesday for our first NetSuite assignment. I will see you all then.